Now let's talk about how to use time value of money to evaluate projects. Example, you're considering investing $1,000 on a project that should earn $400 at the end of each of the first 3 years and $200 at the end of the next 2 years. If the risk-adjusted rate of return for the project is 15%, should you accept the project? So the way this works in net present value is you take all of these cash flows, these are the 400s and the 200s in the problem, and you discount them back to the present. And since the appropriate rate is 15%, we discount at 15%. And this 400 goes back 1 year at 15%. And if you wanted, you could use your present and future value keys to calculate this yourself on a year-by-year basis. This 400 goes back 2 years at 15% to 302.46, and this one to 263.01, and so forth. So we have the present value of those cash flows, and we have the outflow itself. So we're going to take the present value of the cash flows minus the outflow to give us the net present value. Now, in actuality, you could have negative cash flows in the future. For example, you could have a project that requires at some point in the future that there be some refurbishment, and you might actually have a negative cash flow in some future years that's anticipated. At any rate, our decision rule is that we must have a positive net present value in order to take on a project, and that assumes that we have plenty of capital available and there's no competition among projects. So positive net present value just means the value that comes to the firm, which is the present value of these cash flows, which is $1,127.09, is greater than the outflow of 1,000, or we could say greater than the present value of the outflows. So 127.09, positive net present value, that means we should accept this project. Internal rate of return takes a different approach. Internal rate of return says we are going to find that discount rate which discounts these cash flows back to give us a 0 net present value. That is, that rate which gives us a $1,000 present value of these future cash flows. Well, the cash flows themselves, 4 plus 4 is 8, plus 4 is 12, 14, 16, $1,600 worth of cash flows over 5 years to discount to $1,000. Well, that takes a pretty healthy rate. And if we were to try 21%, 400 would be discounted to 330.59, and this 400 to 273.20, and 225.79, and so forth, and we would end up with a 0 net present value. In other words, at 21%, if we discount these cash flows at 21%, they equal $1,000, which gives us a 0 net present value. Now, we use the internal rate of return differently. We compare the internal rate of return to the required rate of return for a project given its riskiness. Anything that has an internal rate of return greater than the required rate of return is an accept decision. In this case, our required rate of return we assume to be 15%. Our IRR is 21%. Therefore, it's an accept decision. Both internal rate of return and net present value will give the same accept-reject signal as long as there is no capital rationing. If we have plenty of money and the projects are not mutually exclusive, then we would accept anything that has a positive NPV and anything that has an IRR greater than the required rate of return. So let's take a look at how the BA2 Plus addresses this type of problem. First, we'll turn it on, and we need to go into cash flow keys. Cash flow keys. Second, clear TVM. second clear work, clear again, and I'm going to go back into cash flows just to check, and I see there are no cash flows in there. I'm going to start putting in my cash flows, and the cash flow at time 0 is 1,000, 1,000, and that's an outflow, so I'm going to put negative, enter, down, and now it wants the next cash flow. Well, it's 400, enter, down, and there are 3 of them, 1, 2, 3. So for my frequency, I'm going to say 3, enter, down, and then I have cash flow of 200, 200, enter, down, and there are 2 of them, 2, enter, down. Now if I wanted, I can check my output, or my inputs rather. I could put cash flow, and I see a minus 1,000, then I see a 400, and there are 3 of those 400s, and a 200, and there are 2 of those 200s. Then I could say NPV, it says what rate? Well, we've been using 10, but this is 15. So we're going to say 15, enter, down, and compute. And it says the net present value is $127.08. Well, if we want to know the internal rate of return, it really doesn't take much effort at that point. We just hit IRR, compute, and 20.9991, or 21% as we used before, would be our internal rate of return. Now notice that it took a second for that IRR number to come up. That's because your calculator is essentially interpolating. It's trying to figure out, okay, let's try 10%. No, 10% wasn't enough to discount this. Let's try 30%. No, that discounts it too far. And your calculator is going back and forth very quickly until it finally narrows it down to 20.9991%.